Hello guys, my name is Craig and welcome to Payment Solutions. If you're new to my channel, please make sure you hit the subscribe button and don't forget to turn on the notification bell so that you don't miss out on any new videos. In today's video, we are going to talk about how we calculate the area that is bounded by two curves or that is bounded by a curve in a line. So to calculate this area, basically we use integration, and right now I'm going to demonstrate how we do that. So for this example here, say we want to calculate this area, right, the shaded region that is bounded by the curve y is equal to x times 5 minus x, and the line y is equal to 2x. So as you can see, if we say the area of this curve, right, from 0 to 3 minus the area bounded by this curve, y is equal to 2x from 0 to 3. If we subtract the 2, we'll get the area that is remaining here. So we're saying the whole part bounded by this curve minus area of this line, we get the area that will remain, which is the shaded area. So, and then now, of course, as well, we'll need the points of intersection. The points of intersection will simply help us with the limits. So in this case, already given that we've got the point of intersection being x is equal to 3, we're integrating from 0 to 3. So we're saying that the area of the shaded region A is equal to the integral of this y is equal to x times 5 minus x, which we can expand, right? Because if we expand it, it's much easier to integrate that way. So this will be 5x minus x squared, right? So we're saying the area bounded by the shaded region is given by the integral of 5x minus x squared by dx from 0 to 3 minus, so this is integral, right, minus the integral from 0 to 3 of 2x with respect to x. So now we solve. So solving this and this we can combine since the limits are the same. So we're saying the integral from 0 to 3 of 5x minus x squared minus 2x with respect to x. And 5x minus 2x will give us a 3x. So 3x minus x squared from 0 to 3 with respect to x, which should be equal to, so now integrating, we're saying the integral of 3x is 3 times x squared over 2 minus the integral of x squared, this would be x to the power of 3 over 3 from 0 to 3. And now substituting the limits, we are saying that 3 times 3 squared, that's 3 times 9, which will give us 27 over 2, minus 3 to the power of 3, that will give us 27. 27 over 3, that will give us a 9. Then this is for the upper limit. So if we say minus the lower limit, substituting 0, we'll still get a 0. So we're saying 27 over 2 minus 9. 27 over 2 minus 9. And then this will give us 4.5. Right? So this will give us 4.5. Write this in black. This will give us 4.5. Let me write it as 4.5. 4.5 square units. So 4.5 square units, this would be the area of this shaded region. So we've basically said the area of the curve above minus the area of the line below. Right. So now let's attempt these 3 questions. Allow me to erase this part. Okay, so for number 1, we need to calculate, this is a 0 here, we need to calculate the area of the shaded region, right? And like I mentioned before, now we need the point of intersection, because this is going to help us with the limit. Already we know that we've got the lower limit 0, but we need the upper limit. So we shall calculate the point of intersection whereby we're going to say for number 1, x is equal to, at this point, x is equal to x times 3 minus x, which is 3x minus x squared. So taking this side, we're saying x squared minus 3x plus x should give us a 0. Then x squared minus 2x is equal to 0, such that x, then x minus 2, and then we've got x is equal to 0 or x is equal to 2. So those are the 2 points of intersection. This being x is equal to 0, then this would be x is equal to 2. So now for the area that is shaded, we are saying that the area of the curve y is equal to 3x minus x squared minus the area of y is equal to x from 0 to 2, right? So we're saying a is equal to the integral of 3x minus x squared from 0 to 2 with respect to x minus the integral of x with respect to x from 0 to 2. And like I said, since the limits are the same, we can combine these to say the integral from 0 to 2 of 3x minus x squared minus x with respect to x, right? And we know that 3x minus x will give us a 2x. So integral from 0 to 2 of 2x minus x squared with respect to x. We're saying that the integral of 2x, this will be 2x squared over 2, minus the integral of x squared, this will be x to the power of 3 over 3, from 0 to 2. Right, and then this would be equal to x squared minus x to the power of 3 over 3 from 0 to 2. Now substituting the limits, we're saying that 2 squared will give us a 4 minus 2 to the power of 3, that will give us an 8 over 3. And substituting for the lower limit, which is 0, we still get a 0. So 4 minus 8 over 3, we'll get a 4 over 3. So 4 over 3 would be the area of the shaded region, right? This is for number 1. Now for number 2, of course we need the points of intersection. So we've got 2 points of intersection. But the one that is of major concern is this one. And this one is going to help us find our limit in such a way that if we get this point of intersection, right, let's call this x naught, right? If we get this value, which is the point of intersection x naught, we shall say that the shaded area of the shaded region is going to be given by the area of the curve bounded by the curve y is equal to x squared from 0 to x naught plus the area bounded by this line x plus y is equal to 12 from x naught to 12. So now our task is to find that point of intersection x naught. So allow me to erase this part for number 1. Okay, so what are we saying? We're saying that for the point of intersection, this could be rewritten as y is equal to 12 minus x. Such that we're saying that at that point, x squared is equal to 12 minus x. This is for number 2. And then x squared plus x minus 12 is equal to 0. Then we've got x plus 4, x minus 3 being equal to 0, such that x is equal to minus 4 or 3. So these are the 2 points of intersection. This being x is equal to minus 4, and then this x naught is equal to 3. So like I said, the area of the shaded region is going to be given by the integral of this curve, x squared, with respect to x from 0 to 3, right, plus the integral of this line, 12 minus x, with respect to x from 3 to 12, like that. And then now we can combine the two because now the limits are different. So we have to work them out separately. So we're saying that for the first one, we've got x to the power of 3 over 3 from 0 to 3 plus 12x minus x squared over 2 from 3 to 12. And now substituting the limits. For the first one, the upper limit 3, we're saying 3 to the power of 3 will give us a 27. 27 over 3, that will give us a 9. Then of course, substituting the lower limit, being 0, we still get a 0. Then we're saying plus. Now for this second part, we're saying substituting the upper limit, we're saying 12 times 12, that will give us 144. So 144 minus 12 squared, that's 144. 144 over 2, that will be minus 72 for the upper limit. Then minus the value of the lower limit. So let me put these square brackets here. So for the lower limit, we're saying 12 times 3, that will give us a 36. 36 minus 3 squared, that will give us a 9. 9 over 2. Like that. So now, if we have to simplify that, we're saying that 9 plus 144, then minus 72, then minus 36, so minus 36, and minus, that will give us a plus, then plus 9 over 2, right, to get a result of 49 and a half. So 49 and a half square units. This is the area of this shaded region. Okay, now let's move on to number 3, which is the last question that we shall look at. Now with number 3 is the same thing. We're simply saying the area of this line, right, with the limits from here up to there, right, minus the area of this curve y is equal to x squared minus 3x plus 8 with the same limits, right? Let's call this x1 and x2. So let's say those are the limits, right? If we subtract those two areas, we get this area, which is the shaded region. So this is implying that we definitely need the points of intersection. So allow me to erase this part for number 2. Okay, so for number 3, we're saying that we need the points of intersection. So we shall say that at these 2 points, what do we know? We know that x squared minus 3x plus 8 is equal to x plus 5. Right, and then now solving for x, we're saying x squared minus 3x minus x, that's minus 4x. Then 8 minus 5, that's plus 3, is equal to 0. Such that we've got x minus 1 and x minus 3 being equal to 0. So x is equal to 1 or 3. So those are our 2. So here we've got 1 and 3. Those are the points of intersection, which will be our limits. So these being our limits, we're saying that the shaded area A is going to be the integral of this curve x plus 5 with respect to x from 1 to 3 minus the integral of this curve x squared minus 3x plus 8 with respect to x from 1 to 3. And now since the limits are the same, we can combine this to say from 1 to 3 x plus 5 then minus x squared plus 3x minus 8 with respect to x. And now we can say x plus 3x, we get a 4x. So integral from 1 to 3 of 4x minus x squared minus 3 by dx. This would be equal to 4x squared over 2 minus integral of x squared would be x to the power of 3 over 3 minus integral of 3 would be 3x from 1 to 3. This would be 2x squared minus x to the power of 3 over 3 minus 3x from 1 to 3. And now substituting for the limits, Firstly, if you substitute the upper limit, we're saying 2 times 3 squared, that's 2 times 9, which will give us an 18, minus 3 to the power of 3, that's 27. 27 over 3, that will give us a 9. Then minus 3 times 3, that's minus 9. So this is for the upper limit. Then minus the value of the lower limit. We're saying 2 times 1 squared, that's 2. Then minus 1 to the power of 3 over 3, that's 1 over 3. Then minus 3 times 1, that will give us a minus 3. So now if we simplify this, we're saying that 18 minus 18, definitely this is giving us a 0. And then this one we're saying 2 minus 1 over 3 minus 3. This will give us minus 4 over 3. So minus 4 over 3 minus, that will give us a plus 4 over 3. So the final result will be 4 over 3 square units. Right? Square units. So this will be the area of this shaded region. Okay, so here we've just been talking about how we would calculate the area that is bounded by two curves or that is bounded by a curve in the line. And please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.